Hello, everyone. I'm Detlef Nauck. I lead the AI and data science research area for BT. So I'm not the head of AI for the whole company. I'm working in BT's research department. I'm based out here in Martlesham Heath Industrial Park. You may have heard about this. This is our research and development park where we are based. And the area I'm looking after is AI and data science. And I'm a computer scientist by training, but I have all my career worked in machine learning and data analytics. So that's my background. About 2 years ago, we started a working group on responsible AI in the company, where we work across all the departments of this large, complex company that is BT, to identify what are the challenges that AI brings when we integrate it into workflows, expose customers to it through products and services. What's the impact on employees and these kind of discussions. We decided back then that we shouldn't put out a set of principles like many other companies have, because you got a proliferation of these ethical principles, but the criticism that came out very quickly is they're not enforceable. So what do you do to really embed ethical principles in AI into the use of AI in an organization? So this is the kind of things that we're looking at, and we're addressing it from a human rights angle, because we have a human rights framework in BT that follows the UN human rights guidelines. And we also obviously have governance processes around data protection and risk management. And we're looking how this these kind of established processes can be applied to AI. So today I thought I give my view on a few issues that we see in AI. So that's why the title, Are You Sure About This AI? So where do we see this going, and what is it that we should be doing in order to manage certain aspects of AI that might potentially be problematic? You have all seen the discussion around the algorithm that was used to kind of fix the A levels for students this year. And this wasn't even an AI algorithm, but this has really increased the discussion around the use of algorithms and the repercussions of the use of algorithms. This, for some time already, is pretty much in the public discussion around bias and all sorts of kind of negative impacts on individuals. And it's probably a good time to have this discussion, because we see more and more algorithms, if I use this word, coming into the kind of public domain and being used for decision making. And there's a lot of naivety behind this. So it is kind of, for this particular scenario, it was always kind of obvious, if you use an algorithm that does a statistical modeling of a population, that you will obviously have individuals that are disadvantaged by the decisions. And how do you manage something like this? And how do you understand, before you let it loose, what these kind of repercussions are, and how do you manage this and mitigate the impact? Clearly, in this kind of aspect, it wasn't done. Therefore, they had to stop the whole process at some point. But you really don't want to be in this sort of scenario when you deploy AI systems in your business. You really want to understand where things can go wrong and manage it accordingly. Another aspect around AI that touches on ethical use is the energy use that we need to build AI systems. So if you look at what's happening in neural network architectures, deep networks, these systems become bigger and bigger and bigger. And here's just a few trend lines for different systems in academia or industry. And this is a logarithmic scale. You see the number of parameters is going up, and the number of parameters are directly related to the computational effort that you need in order to build these systems. just 2 examples here at the bottom. The BERT network, which is used for language translation by Google, has 110 million parameters, and building it required, depends where you look, between $4,000 to $12,000 of compute cost, and the energy usage is equivalent to the carbon equivalent to a flight from New York to San Francisco. These kind of models already become very quickly too expensive to build for smaller organizations. So you can't afford to build these things on a regular basis. And if you look at the latest model in this kind of language modeling space, GPT-3 by OpenAI, this has 175 billion parameters. So it's a factor, more than a factor 1,000 bigger. And it requires almost 2,000 times more compute effort than BERT. So I don't know how that translates into carbon equivalent, but you can see how these trends are going, and it becomes basically unmanageable in terms of building a system like this, unless you're doing it some sort of academic research environment where you might have the funding to do this. And also, if we think of applications AI for good, there's a lot of discussion around use AI to manage climate change, but you can't heat up the planet while you're building these systems. So it's not something that is sustainable. We need to look into this. Another interesting feature of machine learning algorithms is that they love to cheat. And what's meant by this is that essentially they're pattern recognition algorithms, and they're looking for patterns in the data that give maximum information to whatever task it is we are pointing them at. So if we are pointing them at recognizing X-ray images or making decisions about loan applications, they're looking for these bits of information in the data that gives them the best chance to produce high accuracy, because that's what we train them for. We train them for accuracy. And unfortunately, these kind of patterns or features in the data are not normally, sometimes are not the ones that we think the system should pick up to make a decision. And this is what's called model cheating. And a good example is medical images. So there are a lot of examples where AI systems have looked at X-rays or other medical scans to predict anything from cancer to tuberculosis or pneumonia. And what was found is that these systems actually pick up artifacts in the images, which tell them where these images have been taken. So basically which hospital or which X-ray machine. And for example, in the case of tuberculosis, this is very much prevalent in still in the developing world, where you have mobile X-ray machines, and they are transported around, and they create images that can be distinguished from stationary X-ray machines. So basically, what the system has learned is where does this image come from which machine, and this information was used to predict if there's tuberculosis present in the image or not. And so it hasn't actually learned anything about understanding an X-ray image. So this is called model cheating. And if you can't look inside the model, if you can't understand why a model makes a certain decision, that's something you won't pick up on. And it's actually, if you work in machine learning for a long time, then you have heard this story that was discussed in the 1980s already. This is when they used neural networks and they tried to detect tanks hidden in forests. So it was a military application. And so the system worked fine. It detected tanks, but it later turned out the only thing that it really detected was trees. And so they trained the system with pictures of tanks hidden in trees and other landscape pictures where there were no tanks. But what the system learned was distinguish between trees and other landscape pictures. So it hasn't actually learned what they thought it would be learning, and this is still going on. So this is something we actually know about for 40 years, that machine learning systems do this. And sometimes these things get forgotten. And if you now look into systems that are much bigger, much more complicated, it's very difficult to pick that up. So in terms of responsibility in AI, obviously, bias is the other big topic that everybody talks about. How do we make sure these systems are not biased? And we all know that bias is already present in the data. Any sort of AI system is trained on historic data. That means it can only replicate what has happened in the past. But we all know that we don't want to replicate the past, so we want to get to a better future. And that means we need to very carefully look at the curation of the data that we use to train systems. We need to be aware that there's always bias present in data, and we need to make sure that we detect this, because bias, like in the model cheating kind of topic, bias is something that helps machine learning to make more accurate decisions. So it will pick up any sort of bias that is linked to the target that it is supposed to predict, and because it helps making this prediction, and then we are seeing the negative effects. And so sometimes you can guard against it by understanding what your data is and what the bias might be, but you need to understand the protected attributes in the data. So for example, gender, race, age, income, whatever it might be, that where you want to guard against bias, you need to be able to find that. But data protection sometimes means you can't have certain attributes in your training data for your machine learning model. So if you're not supposed to know gender or race for training, then your system can still be biased. And the Amazon CV scanning tool is a good example. So they found out very quickly when they trained it that it was biased against women, because there are fewer women working in technical roles. And so that's obviously something you want to correct. And so they were taking out the gender information, but the system still picked up on this bias because it found other attributes in the data that are kind of correlated with gender. So that could be types of sports that are more done by women than men, or particular names of colleges that is women-only colleges. So it picked up on these kind of subtle correlations and still then managed to discriminate against women. So they basically scrapped the whole system. So this is something where you need to understand this can happen. And then data curation is your only chance to get out of this. So you need to basically create a data set of the future that you want to have, not the past that has given you this data. And this is obviously requires a lot of effort and insight when you build AI systems. Transparency and accountability is the other area where we look into. So how do we understand what AI systems are doing? So if they give us a decision, how do we know it's a good decision? And or maybe more important, how do we know this is a wrong decision and we cannot follow it? And how do we make the systems accountable for it? So who is accountable? Is it the person who collected the data that was used to train the system? Is it the person who trained the system? Is it the person who purchased the system and applies it? So there's a kind of a complicated chain of responsibility and accountability in this. And you know, from software, when you buy software, you still, if you look into the terms and conditions, you still see this, that the software that you buy is not guaranteed to be correct, because it says that it's impossible to guarantee bug-free software. And if you go into creating an AI system from data, then you make it worse, because now you have data that is not necessarily correct and you have software that is not necessarily correct. So these kinds of issues can compound. So how do we do this? And there's a lot of activity in that space. We will certainly see a regulation happening around accountability in AI. And the ICO has drafted a framework already. And so there's discussion around it for example, treat it in a similar way to medicine. So you can say when you release medicine into the market, you know that there might be side effects and they might be more or less dangerous, and you have to list them and make people aware. So this is a headache pill and it's 99% safe, but 1% side effects could be leading from nausea to anaphylactic shock, whatever is possible. You have to tell people that there are certain risks involved in using this medicine. And you could have a similar approach for AI systems to say very clearly that this system might make wrong decisions and that you have to mitigate for this. But this is very much an area under discussion. Another aspect is the complexity of these systems is growing because we are using basically libraries to build them. And we are not really understanding what's in these libraries at any given point in time. This is not only affecting AI, but it affects complex software systems at large. Just one example would be autonomous vehicles, autonomous cars. So if you think about what is built into them, you have camera systems that have to take pictures of the road, pick up traffic signs, pick up pedestrians, cyclists, other cars. You have the same thing as a LiDAR system, a laser system. It works like a radar system. You have decision-making software. You need to understand traffic rules. You need to understand there's an obstacle. How do you control the car? You need to understand how you accelerate, go around corners. So there are multiple modules in these cars that work independently but have to work together to perform and give a safe autonomous vehicle. And you know these accidents that have happened, and for example, the Uber accidents where this lady was run over and killed because she was pushing a bicycle across the road. When they analyzed what had happened, they found that the image recognition system picked up this person, and but then decided it wouldn't be a person, it would be an obstacle, and that the car should steer around. Then the system realized this obstacle is moving, so it changed its decision, but then it was too late to steer around. And another system that was used for emergency braking actually had been shut off. It was one of these Volvo SUVs that have an automatic emergency braking system, which Uber disabled because it was interfering with the autonomous control of the braking system. So the car realized it can't do an emergency brake, and it alerted the driver, who was doing something on their phone or controlling the system on a tablet or something, but basically was in no position to take over and brake. These things happen in complex systems, so it's not just that you may have an AI system that is not trained optimally. You have complexity arising from combination of software systems that you put together, where you not necessarily understand what's going on in each of these individual algorithms, and they call it Franken algorithms. So you put something together out of code items that you may not perfectly understand. And this is where the issue of understanding what's going on in AI touches on kind of understanding what's happening in software in general. And if you look into this, you find there's no way of proving that the software that you have written actually does what you want it to do. There's no kind of generally available software verification or software quality assessment that can be done. And so we're basically living in a system that is already imperfect because we can't fully figuring out what's happening in software. And now we're adding the kind of uncertainty of AI on top of it, which means we really need to get to grips with this area. I want to talk a little bit about understanding what's happening in AI systems, and that touches on explainability. And there's a concept in science, it's called Occam's razor. And the idea is that if you have the choice between two systems that are performing equally well, then you pick the one that is simpler. And you do this because it is easier to test a simpler system than a more complex system. And so this is a principle in science that has been applied for generations. And we're not really seeing this followed in machine learning and model building. So as I said at the beginning, these deep neural networks that are used in image recognition, speech recognition, and so on, they become bigger and bigger and bigger, and they become more and more complex. And nobody is really looking into the idea, how big do these systems really have to be? Can we get away with something that is much smaller and more manageable? So currently, we are in this kind of era where we're just throwing resources at machine learning to make the systems better. We're not at the same time working on understanding how we can make them smaller and more manageable. I like this quote here from George Box to remind myself to be a bit more humble about what I do. Machine learning builds models, and all models are wrong. And they are a simplification of the data that you use to build them. They're a simplification of reality. The data is already a simplification of reality. So whatever you build, it is wrong. Sometimes it's useful. And when I say it's wrong, that means you will have a residual error in your AI system. AI systems are never 100% correct or perfect. It's not possible. If they are, you made a mistake in building them. So you have to approach AI systems with this sort of understanding in mind, that you're working with a statistical model that is imperfect and will produce errors. So how do you manage these errors in your application scenario? How do you mitigate the impact these errors will have, which you can't avoid? The problem is that simple systems are not always good enough. So you can't necessarily say, okay, throw away deep networks, let's go with something like a small decision tree. Depending on the kind of application, you might actually require a complex system. And but then you still want to understand what this complex system does, how it has been built, how it performs. So just the excuse that I need something really complex because I don't want to just sail through the air, I want to fly to the moon, fair enough. But then you want to understand how this complex system actually works and how you control it. Basically trying to figure out, how do we get explanations from AI systems, and why is that? Why do we want explanations? And there's this idea of good science, trust, and causality. So you want to understand that the system that you have built is actually following some kind of scientific principles, that it will produce reliable outputs, that you can trust it, that there's causality kind of built in, that it's not random decision-making based on data that has nothing to do with the problem you're looking at. So I just point back to the medical imaging, for example. You want to make sure that the system really picks up on pneumonia or cancer, not that it picks up on artifacts of the X-ray machine. Ethics and fairness, obviously, you want to understand that the system is not biased. So you don't want to find this out down the line when you've already released it into the wild. And we all know the stories around facial image recognition, how that is biased, and that is used even in policing scenarios. And this is a massive problem. So you need to be aware of this. And if your system can tell you how its decisions are being made, you have a much better chance of picking up bias, because you can then say, that doesn't sound right. We should look into it. You want to challenge the outcome of decisions, and you want to follow legal and regulatory obligations. And this touches, for example, on GDPR, where you may have the right to have an explanation from an automated decision-making scenario. So if an algorithm makes a decision that significantly impacts you, you can ask for an explanation. And that means you have to build your AI system in a way that it can deliver it. And obviously you want to learn from mistakes. So if something goes wrong, you want to be able to say, this is why it went wrong, and this is how I prevent it from going wrong again. This is where we can look, for example, in the aviation industry. Anything that happens with an airplane is analyzed and studied to the nth degree to really understand why there has been an accident, and the learning is applied to the whole industry. And there's a very strict procedure for this that we have to go through if we have an accident with a plane. And so something like this should be applied as well in AI, especially in areas where we apply it, where it has significant impact on individuals. Unfortunately, getting explanations out of AI systems is not trivial. Sometimes explanations are not helpful. So here's an example. This is an image recognition system that creates labels for pictures or answers questions about pictures. So the top row, the question is what is covering the windows? So the answer is blinds. And if you track human attention, so check where in the picture people look at when they answer this question, you can clearly see these kind of activation hotspots around the windows, at the top of the windows. And that means somebody looks at this picture with an understanding of the context, knows blinds attached to windows, and this is where you have to find them. An image recognition system that was used to answer the same question and can answer it correctly doesn't even look at the windows. It looks for some reason at the bed or at the lamp, and it decides the answer should be blinds. We have a little bit of attention on the second window, which is just peeking into the picture. But it's clear that the decision here has been made on something completely different, and it's not looking at the blinds. Second row is the same thing. What is the man doing playing frisbee? Human attention where you would expect it, while the machine attention doesn't even pick up the frisbee. So it looks at the tree, it looks at the grass, and something very interesting seems to be happening at the bottom left corner there, but clearly has nothing to do with playing frisbee. So getting explanations out of AI systems is still a very open question, and it's not clear how we do this. And it's also not clear what is an explanation. So what is an acceptable explanation that comes out of an AI system? Is it something that is aimed at an expert? So here the like a dashboard in a plane that is aimed to give information to the pilot, and then you and I would just stare at it and just see a lot of dials and numbers and have no clue what it means? Or is it something like that has to be like a dashboard in a car where we all can understand, okay, this is the speed and this is what the car is telling me, and I can clearly understand what that means. So it's a completely different kind of scenario, and most explanation systems are more in the kind of dashboard for pilots kind of scenario. They wouldn't produce anything that a layperson can really take away and understand. So it's very much an open research problem we need to work on. A very refreshing counterpoint to this is the idea that we shouldn't really try to explain what a black box does. We should build interpretable models instead of building black boxes. So if you look into the work done by Cynthia Rudin, she follows this approach. Let's build an AI system that is as small as possible and as transparent as possible, so that I really can look into and understand what's going on. And she actually won a couple of competitions against deep networks by following this approach. So yeah, this is more in the kind of tradition of good engineering. So you build something that you can control and understand. It means you put more effort into it, right? So we have to get away from this idea, or I just chuck a lot of data into a very large system and let it churn to produce a solution, because this is easiest for me, because I don't have to make any kind of put any intellectual work into it. And so the discussion in this kind of building massive deep networks is more like people are likening it to alchemy instead of science. So I found something that produces something. I don't really know how it works, but it does something. But creating something that I fully understand, can control and interpret is much harder. You need to put more mental effort into this. So the kind of mental elbow grease that we need to put into building AI systems has to really go up. AJ asked me to point out a few useful frameworks that you might want to look at if you think of adopting an ethical framework in your own organization. And there have been a lot of frameworks put out by Microsoft, IBM, Google, so the kind of tech companies came out with these frameworks. The criticism on those was always, how is that enforceable? So you have this high-level goal, my AI system should not be biased. Well, how do you make sure it's not? So here's something very interesting coming from Rolls-Royce, and they really applied engineering principles to look at this problem. And so they're using AI for their engine management systems. They basically use AI to predict what's the state of an engine in flight in the next 15 minutes. And they use this to pick up on problems before they happen, so they can manage this, and they can do preemptive maintenance and these kind of things. If you do something on something that critical, then you want to make sure it's really correct. So the engineering effort that went into building these systems and the kind of checks and balances that they have built in comes from their understanding of doing quality management in engineering. And that has really flown through into quality management in building AI. So I would recommend to have a look at the system. I saw a presentation about it in January already, but they're now releasing it and they're making it open source, so you can get your hands on it. Another one that is also very practical and approachable comes from the Digital Catapult, from their machine learning, machine intelligence garage. This is a framework that is supposed to help startups to get their head around AI ethics and have a very clear system of 7 concepts that you can follow. And I found this very clear and kind of easy to apply. So it's not an engineered system that actually comes with software, but it's a nice way of framing it and making it relatable. So this would be my recommendations for frameworks to look at. And I just want to close with this phrase: ethical AI is good AI. And this means if you are looking into building ethical AI systems, then you realize that you have to put a lot of effort into engineering them, a lot of effort in understanding the data that goes into them, and making sure it's not biased, it doesn't have errors, that your system is not cheating. So all of these things that you have to control to make sure that your system behaves ethically also means you're getting a system that performs really well. So the effort into putting the effort of putting into AI that makes it ethical also makes it perform well. So it's not wasted effort. It's not something that you do extra because you have to. It's something that really helps you produce something of value that performs well. All right, thank you very much. And I hope it was interesting, and looking forward to a discussion.